Welcome to electron spin and the Pauli principle. So we've already talked a little bit about the fact that electrons have this magnetic spin associated with them. Now, the Pauli exclusion principle says that in a given atom, no two electrons can have the same set of 4 quantum numbers. So remember, the quantum numbers describe the state of an electron within an atom. And the Pauli principle, the Pauli exclusion principle, is saying that no two electrons in the same atom can have exactly the same value for all 4 of those. Now, any one of them could be the same, or 3 out of the 4 could be the same, but one of those 4 quantum numbers has to be different for 2 or more electrons. So, since electrons in the same orbital have the same values of n, l, and m sub l, the principal quantum number, angular momentum quantum number, and magnetic quantum number, that means that the electrons must have different values of m sub s. They have to have different values for the spin. So one of them has to be spin up and one of them has to be spin down if the electrons are in the same orbital. And this is why each orbital can only hold 2 electrons, because we only have 2 possible values for the spin. They can either be spin up or spin down. So if those 2 electrons are in the same orbital, then those are the only 2 possibilities. If we go putting a 3rd electron in there, well, we can't, because we don't have a way of getting those 4 quantum numbers to be different in that same orbital. We have to put that electron into a different orbital. So again, since there are only 2 allowed values of m sub s, this means that an orbital can only hold 2 electrons, and they have to have opposite spins. So when we draw a diagram showing where our electrons are, by convention, this sort of diagram is called an Aufbau diagram that I'll describe more in a future video. So we have energy going up as we move up on the screen. So for something like hydrogen, we only have 1 electron. We'll put it into the 1s for now. By convention, we put the first electron in an orbital in going up. So an orbital here is shown as a horizontal line. So if we have a horizontal line, we have 1 orbital, that's our 1s orbital. We're going to put our electron in spin up. Again, it doesn't matter whether we put it in up or down, really. Just by convention, we put the first one in an orbital pointing up. Now, if we go with helium, now we have 2 electrons. Well, we put the first electron in, we'll put that in spin up. If we go to put our second electron in, we can't put it in spin up, because if we do, well, now those 2 electrons have exactly the same set of 4 quantum numbers. The first 3 are the same because that 1s, there is only one 1s orbital, which means that the 1 is the same because the energy level is the same, 1, so n is the same. L is the same because s has an L of 0. And there is only one 1s orbital, which means the m sub l has to be the same, 0. And if we put that other electron in spin up, then that means that m sub s is the same. Well, that means that all 4 values of the quantum number are the same. That violates the Pauli exclusion principle. We have to put in that second electron spin down. So we put in our first one spin up, our second electron has to be spin down within that orbital. If we have a different orbital, if we had another orbital that was at the same energy, we could put that other electron in spin up and we'd have no problem. So that was electron spin and the Pauli principle.